Gathered here for this very wonderful occasion of learning calculus. Okay, and so somebody had a homework question from 3.6, right? And somebody asked about number 8. Can you tell me what the problem is? F of x equals
4x over x squared.
The whole thing squared?
Yep.
Quantity squared. Okay, so f prime of x is going to be, well, okay, you know what? I like to think of it as a product rule. So 4x times x plus 1 to the negative second power. Okay, so I'm going to do 1 d2 plus 2 d1. Okay, so the product rule is so much fun. It's 1 d2 plus 2 d1. So 1 d2. The derivative of this one is negative 2 times x plus 1 to the negative third power times the derivative of the baby. The derivative of x plus 1 is just 1, right? So that's 1 d2 plus, yes?
You did the derivative of the big one, of the big fish, times the derivative of baby?
Yes. So here, the 2 is something to the negative second power. And the derivative of that is negative 2 times that something to the negative power times the derivative of that something. Got me? Yeah. So this is 1 d2 plus 2 d1. Let that sink in. Are we having trouble with the d2 part?
Yeah.
Okay, so what is 2? This second function here is something to the negative 2. So when you do the derivative of something to the negative 2, what do? You bring the negative 2, the exponent to the front, so it's negative 2 times that something to the negative third power. But now you have to do the derivative of the something, which is the derivative of 1x is 1.
We're doing like 2 derivatives.
No,
No,
that's the chain rule. The chain rule is the derivative of the something, no, the derivative of the function times the derivative of the baby.
Is that the dy dx?
Yes.
df dv?
Yes. Let me explain this part over here. Okay, so let's see. How shall I explain it? So this part, let's call this let's just call that, what should I call it? T, okay? T for 2, okay? T equals x plus 1 to the negative 2, right? Think of it like this. T equals something to the negative 2, okay? How do you find the derivative of that something? The derivative of t is going to be negative 2 times something to the negative 3, right? But when you have the chain rule, you have to also do the derivative of that something, right? And what is the derivative of that something? Depends on what's inside, right? So let me rewrite it. Okay, so t prime is going to be negative 2 times that something to the negative 3. But what is that something? That something is x plus 1 times the derivative of x plus 1. What's the derivative of x plus 1? 1. That's the chain rule. It's different if that something was just x. If t just equaled x to the negative 2, then it would just be t prime equals negative 2 to the x to the negative 3. That's just the power rule. But if we're trying to use a power rule on a composite function or composite function, and that x is not just an x, it's an x plus 1, then we have to do the derivative, multiply by the derivative of the inside, the x plus 1. So it's the derivative of the mom is this, times the derivative of the baby, which is this. Yeah? So the big picture is the mom, and the womb, inside the womb is the baby. Okay, so derivative of the mom times the derivative of the baby. But you have to do the derivative of the mom with respect to the baby. Respect the baby in the mom. Okay? Okay, yes, Robert.
Where did the 1 come from?
This one right here?
Yeah.
It's the derivative of x plus 1.
Why do you find that?
Because that's the baby, and you need to do the derivative of the baby. Yeah. Does that make sense?
Yeah.
Let me see if this will help at all.
On the video, does it show that? Like you go into
The video?
yeah.
The video just showed us like what we did in class.
No, I mean also does it show this?
Oh, this? Oh, yes, yes, yes.
Oh, okay.
So look, you guys. If A is something cubed and B is what the heck? Okay, so these are just okay. So if A is something cubed, the power rule with the chain rule, A prime is going to be 3 times something to the second power times the derivative of the something. Does that make sense?
Yeah.
Okay, like B, okay, well we didn't learn the log rule yet, so just pay attention to that for now. That makes sense? Times the derivative of something with respect to t. Oh wait, what? What's t? Never mind. Okay? Alright. Does that make sense? Okay, so we did that and then we just go on from there. Carry on. So we have negative 4 times negative 2 times 1, so that's negative 8 x times x plus 1 to the negative 3 plus 4 times x plus 1 to the negative 2. That's our final answer. Okay?
Can you bring the negatives to the bottom or no?
To the bottom?
Yeah, like the negative exponent.
Oh, you can. So you can say negative 8x over x plus 1 to the positive third power plus 4 over x plus 1 to the second power. These are both acceptable. Number 10? Okay. All right. Any other questions on this problem, particular problem? Satisfechos? Okay. Number 10. Can you give me the function, please?
Y equals x cubed times 5x minus 1 to the 4th.
Like that?
Yeah.
Okay. So, big picture, what is going on here?
Something being multiplied.
It's product, yeah. Something's being multiplied. So this is 1, and this is 2. So 1d2 plus 2d1. So y prime equals 1, which is x cubed, times d2. What's the derivative of this? Well, this is something to the 4th power. So we're going to say 4 times that something to the 3rd power times the derivative of the baby, which is 5. That's 1 d2 plus 2 d1. What's the derivative of x cubed? 3x squared. Okay? And then, are you guys worried about the way the answer key did it?
Yeah.
What did the answer key say?
About like 35.
Okay, so let's factor out. What do you think we can factor out? 5x minus 1. How many how many times? 3 is the greatest common multiple, right? What else can we factor out? What about x?
X cubed squared.
X squared, yeah? Okay.
Well, how can you we're factoring out from the first
From both.
one.
Because look, basically on a big picture level, you have now a sum of products. You have this plus this, but these both have 5x minus 1s, and these both have x's. Right? So if I factor out the x squared from here, I'm left with 1x. Well, let's see, we have 20 here, right? I'm left with 1x And I'm left with no 5x minus 1s, right? And then if I so this is 3,
Wait, why do you have 20x?
because I had the 5 times 20 here.
And where did x come from?
Because there's x cubed, but I factored out x squared. And then we have 3x squared, so x squared came out, so we just have 3 left. And we have 1 multiple of 5x minus 1. So this is kind of this is no longer calculus, it's just reviewing our algebraic tools. And then we might want to simplify that. So it's 20x plus 15x minus 3. Which is 35x minus 3. Beautiful. So we can factor. Like when you see these common multiples, doesn't it just call out to you and make you want to factor? A little bit, right?
That's the answer.
Yeah. Is it?
Yeah.
Yeah. Yes? Yes. Sign out. Other questions from the homework? Tarea, tarea. No hay preguntas. 30. 30? 30, 30. Wow. I'm assuming that, okay, so 30 says to find this. Is it like this? Yeah? I'm assuming that means f to the third power, right? Okay, because other times that 3 can represent the triple derivative, third derivative, but in this case, no. So don't worry about that. Okay, so the derivative of this, sometimes it's, I don't know, that's not technically, I don't know how legitimate it is, but sometimes you'll see people just do that, like the videos that Mario's been watching when he's been cheating on me. So sometimes they have that, and it's fine if you watch other videos. I'm fine with it. I know, I see how it is. Okay, so if you do the derivative of that, okay, that symbol, I guess, is the derivative of the whole thing, which I don't know, I wouldn't use it like on like a test, but you can use it like on your homework to help you know that you're doing the derivative of that. So it's still a product, right? So this is our 1 and this is our 2, right? So 1 is still this times d2. That's g prime of x plus 2 times d1. So let's do it like this. F to the third power of x primed. Okay? Now we're evaluating all of this at x equals 3, right?
Yeah.
So what's f of 3? It's 1. And what's g of 3? According to the chart, 8. And what's g prime of 3? -5. Okay, is that all we need? So here we have f of 3 is 1, so that's 1 cubed. Yeah, because basically now we're doing 3, 3, 3, 3, right? F of 3 is 1, and this is saying f of 3 f of x cubed, times what's g prime of 3? It's -5, plus, this is a good AP problem, by the way. G of 3 is 8 times, okay, wait a minute. What is the derivative of f of x to the third power? we have to do 3 times f of x to the second power.
So you can't take the derivative of f of x and then keep that?
No, because that's the chain rule. You're doing the derivative of this whole thing. You're not doing the, it's not f prime of x cubed. Okay? It's f cubed of x primed. See what I'm saying? It's different. You get me? How it's different? This one is doing the f of x and then multiplying it by itself 3 times and then the derivative of that function. This is finding the derivative of just the regular f of x and then cubing the derivative. Here you're deriving the cube and here you're cubing the derivative. Ooh, I like that.
Wouldn't it be 1?
Huh?
Wouldn't it be 1?
What?
F cubed of x.
F cubed of x. Well, yeah, because f cubed of x is 1, and then you do the derivative of 1 is 0. Okay, well, whoa. No, not quite. Because look, the derivative, okay, of, okay, f is a function cubed, so we have to do 3 times the function squared times the derivative of the baby, which is
1.
f prime of x.
Oh.
Right? The baby is f of x. Do you see that? In this, the baby is f of x, and the mama is x cubed. Do you see that? Okay, mama is going to be in pink, okay? Mama is something cubed. And the baby is f of x. The baby is f of x, and the mama is taking that baby and cubing it. That's what the function is. That's what it means to do f cubed of x, right? And if you want to do the derivative of that function, you have to derive the mama and multiply it by the derivative of the baby.
So derivative of mom is 3x squared.
Yes. Derivative of the mom is 3 times the baby squared. You with me, guys? So, now we're going to plug this in. So what is, if we're going to put 3 in here, so we need 3 times, what's f of 3 squared? What's f of 3? 1. So 1 squared times what's f prime of, what's
Wouldn't it be the derivative of 1?
no, we do that later. Okay, so keep things in terms, you plug it in at the end. So what's f prime of 3 on the chart? Negative what?
Negative 3.
Negative 3. Okay, so basically all of this is this, which is this. Okay? Which is 1 times negative 5 plus 9 times 8, which is 72. Negative 72, which is negative 77. Is that the answer?
Isn't it negative 9?
Yeah. That's why it's negative.
Oh.
That's the answer, right? I think you guys need a minute to process that, huh?
Yeah.
Okay, so take a minute or 2 to process that.
I think what confuses us is the I thought because you plug in 3 to the x, so it would be 1. And then that would, you would have to find the derivative of 1.
No,
instead of the
that's
f
too
of x.
soon. You're plugging in too soon.
So we should get used to plugging in at the end. Like plugging in the numbers like
Because with all of these, if you just did it right from the start, you would just get constants, and the derivative of a constant would be 0. So every derivative would just be 0. Okay. Are the other ones kind of similar?
somewhat.
Yeah, these are like, these types of problems are on the AP test. So, the nice thing about the AP test for calculus is that you already know what you're gonna get. There's not gonna be anything on the AP test, hardly, that like, woo, I've never seen that problem before. Like, they're all stuff that we've seen. So long as you're able to do everything and understand everything that I show you, even if I have showed you it only once, that's how it looks. It's not a big surprise. Okay. Do you have other questions on this? Oh, look, Emilio. He had his first math midterm.
Already.
Yeah.
Berkeley, no trouble. Midterm, no.
When did birthday start?
End of August. Same as you. You guys had your have your first midterms next week, and they usually have 2 midterms, not just ones in the middle. Math classes and science classes usually have 2 midterms. One like 1/3 of the way, and then another 2/3 of the way.
So he just took it?
Yeah. Anyway, all right. So I know, that's so true. UCLA starts this week.
Starts this week, but they haven't started. I'm pretty gonna start.
But I told you, didn't I tell you guys, they're on a quarter system, so they have a different. Berkeley is the only UC that's still on the semester system. Every other UC is on the quarter system, which is 10 weeks instead of 15 or 20 weeks. And so you have 3 quarters in 1 year. I don't know why they call them quarters. Well, they're called quarters because there's also summer quarter, but most people don't take the summer quarter. So it's quarter system, 10 weeks, 10 weeks, 10 weeks. So classes go by fast. And you have you start school and already next week is midterms. It's like that. Like if you're in a science or math class, it's like you start school and then next week it's like prepare for midterms, and then 3rd week you have midterms, and then 2 weeks later you have another midterms, and then 2 weeks later it's like finals, and then you're done. And so it's really intense. But actually, if you talk to most UCLA students, they like it. Like at first they freak out their freshman year because they're not used to the pace, but then they actually really like it because it's just fast and furious. It's really intense. They don't, yeah, and you just like pack in the learning. No time to like when I went to semester school, and seriously, it was like for the first month you're like just easing into it, you know. But there it's like they learn a lot. They only take 3 or 4 classes though, a quarter. But you're taking more classes, and every class you get done with it quickly. Like before you start feeling the pain, it's already over. It's like doing sprints versus running marathons, you know? So kids actually like it. All right, other questions before we move on?
17.
Okay, we can do that one real quick then, okay? 17, all right, so I like to do problems when I feel like you guys have really worked hard on it and you just still have trouble. I don't like to do problems when I feel like you didn't do the homework and you're just asking because you're lazy to like try to persevere on it yourself. But I feel like you guys worked on it. So y equals the square root of what? Cubed root of?
2t over t squared
minus 4. So I like to rewrite this as 2t over t squared minus 4 to the 1/3. Okay. And if we really like the product rule, we can even go so far as to say 2t to the 1/3 times t squared minus 4 to the negative 1/3. If we really dislike the quotient rule, we can make it into a product. See that? It's negative 1/3 now. Because that was in the denominator.
I think it's like the back part.
Okay. I like how you talk in the plural. That's nice. Okay, so y prime, I'm going to use this one. 1d2 plus 2d1. So 1 is 2t to the 1/3. Derivative of this one is going to be, bring the negative 1/3 to the front, keep the baby in the mama, and then subtract, so 1/3 minus 1 is negative 4/3, right? Times the derivative of the baby, which is 2t. Okay, you need your parentheses, okay? Make sure you use your parentheses correctly, okay? Some of you guys have bad habits with your parentheses. That's 1d2, yeah. Plus 2, which is t squared minus 4 to the negative 1/3 power, times the derivative of 1, which is 1/3 times 2t to the negative 2/3. Say that again?
Like the same thing as 2t over 3 to negative 2/3.
Yeah. No.
You multiply that 1/3 to the 2 on the outside, right?
Yeah. Okay. Are there questions on this? 1d2 plus 2d1. Any questions on the d1 or the d2? No questions because you get it or because I killed you and you're not even conscious? No response. Just check these. Okay. Okay. So, hello? Are you guys okay so far?
Yeah.
Okay. All right, so let's just simplify. Wow, this is ugly. Okay, let's just try factoring right now. What do you guys see that we can factor out?
2t.
The 2t's? Okay. T squared minus 4. That can be factored out, right?
Would you factor out negative 1/3?
That's a good question.
Then you'd have
Should we factor that out? Let's try that. And then should we factor out a...
You can't factor out a 2t?
Yeah, we can. Let's do that too. But how many of them should we factor out? I mean, to be honest, it's like subjective, you know? You want to factor out 1/3?
Well, negative 2/3 is the least.
True. Well, really, it's really subjective. If we want to make it look like the answer key, what did the answer have as the... When I say subjective, it's like, it's kind of an art.
It has negative 2t squared
Square minus 8.
minus 8 over 3 t squared minus 4 squared.
So they factored out 2/3. Well, they didn't even. Yeah. I don't know if I would do that. Yeah, let's factor out 2/3 of it then. Fine, let's factor out 2/3.
Wasn't there the 1t to the 1?
Let's do this. Before we factor, let's just see what this thing actually looks like. Okay? So to see what it looks like, this is the constants. Okay. Oh, first of all, we could combine these, huh? There's 2t here and 2t there. So how many 2t's do we have? We have 2t to the 1/3 power and to the 1 power. So yeah, to the 4/3 power. Okay. And then we have negative 1/3 in the front.
Which was the negative? Oh.
Okay, then we have t squared minus 4 to what power?
To the 4/3.
Negative 4/3 power.
Put that on the top.
Yeah. Yeah, we can. Okay, plus we have 2/3 here. And then we have,
It's not negative.
is it? No, I don't think so. 2t to the negative 2/3 times t squared minus 4 to the negative 1/3. So on the side, I'm just gonna, well, I guess I don't have to do on the side. I'm gonna rewrite it on the top and bottom, like you said. So this is 2t to the 4/3 on the top, and 3 times t squared minus 4 to the 4/3 on bottom. This is negative though. Don't forget the negative. Nasty negatives.
What's negative?
In the front right here. Okay, and then we have 2 times 2. Oh, it's just 2 by itself over here, huh? Over 3 times 2t to the 2/3 times t squared minus 4 to the 1/3. So that tells me that I can take out, like you guys said, it's weird to have it on the top and the bottom, huh? Like here we could obviously take out 1/3, t squared minus 4 to the 1/3. But then what about the 2t? So if I take it out of here, yeah, so how much did they end up taking out? Okay. Interesting. Okay, let's do that. If I were to take out from here 2t to the, huh?
We're going back to the front.
Back to the what?
Like, so we're ignoring this. Or what do we do?
I just wanted to see what it looked like, because now, yeah, I'm factoring out from here or from here, from either one. Okay, so I'm gonna zoom out a little bit. Can you guys still see? Okay, if I take that out and I take out okay, I'm gonna take out 2/3 of this, and I'm gonna take out negative 2/3. Wait. What was it? Was it 2t on the top or the bottom? On the answer key.
2t, just regular 2t
Uh-huh.
on the bottom.
So it's on the bottom. So yeah, let's take out a negative 2t. Now, okay, when is this important? Because if it's on an FRQ or something, you could do this one, and you're still correct. The only, because any simplified equivalent expression is correct. There's no one more correct answer over the other as far as FRQs are concerned. This is correct, this is correct, this is correct. Any of those is correct. The reader will have to decipher if what you have is equivalent to the answer. And in fact, if you're going from here, you're better off leaving it like this than to go here, because you could accidentally make a mistake and forget the negative. And if you had it right here, but you forgot the negative when you got down to here, then your final answer is wrong. And so you don't necessarily have to simplify stuff on the FRQs. And in fact, the more you simplify, you can make a mistake and get yourself wrong. It's important to talk on the FRQ, but if you talk too much, you could hurt yourself. But this is only important, let's say, on a multiple choice, and they say, which one is the correct derivative? And this is not on there. But let's say only this final answer is on there. You have to be able to know that this is the same as what is the derivative. So in that sense, you do need to know how to simplify. Does that make sense? For multiple choice. Because if they have this there, and you're like, wait, my answer's not there. This answer's not there. It doesn't mean the answer's not there. Maybe they simplified it. Okay? So let's factor that out. Okay, and we've got to, okay. Do I even have space? Okay, so if I took out a t squared minus 4 to the 2/3 power here we had negative 4/3. If I took out 2/3, what does that leave us with?
Wait, how could you well, are you taking it off of both sides or just
From both, yeah. So from
That's the
here,
1/3 on this right side.
on the, yeah. So,
Wait.
what am I left with? Because I'm doing whatever I have here, subtracting this. So negative 4/3 minus 2/3, I'm taking away negative
-6.
6/3, which is negative 2. So I'm going to be left with t squared minus 4 to the negative 2, right? And then I took out 2/3 here, so I'm left with, no, just positive 2/3, right?
Yeah.
Wait, oh yeah.
The 3? This one? What? I don't want to take out a 1. Oh, I guess I could take out a 1/3. Yeah. I'm going to take out a 1/3. You're right, because we have 3's here and 3's here. So then I have negative here, though. Don't forget the negative. I hope this is leading somewhere. I feel like I'm taking you guys into the woods.
Yeah, I feel like I'm getting lost already.
Okay, so negative. Let me just try to finish it real quick and see if it actually matches anything. Okay, so okay, so I took out 2/3, and so I'm left with 2/3. Okay, plus I took out, so I have 2 here because I took out a 1/3, 2, and then I took out negative 2/3, so I'm left with nothing here, and then I took out 2/3, so 1/3 minus 2/3 is negative 3/3, which is 1, yeah? So t squared
Where are you right?
minus 4 to the negative 1. Okay.
Oh, that's what you're talking about. That you couldn't fit it in.
Oh, yeah. I think there's a light at the end of this tunnel, though. Some of you guys are like, OMG. Okay, so then we have, whoa! Okay, wow. Okay, so I have 1/3 times 2t to the negative 2/3 times t squared minus 4 to the positive 2/3 times I'm going to switch the order here.
I got lost when she went back to factor out 2t. 2t to 13.
Wouldn't it be to the negative 3 if you subtract 1 from negative 2?
Say that again?
You know how you put 2, yeah, wouldn't it be to the power negative 3 there?
Here?
No, on to your
Was
left.
it normal
Right there.
equation
No,
t?
no, to your right. Right to the 2 times 2t minus 4, that, yes. No, right there. You
This
did
is
the
just
derivative
number
of the
17.
top, right? Of the, wouldn't it be to the negative 3?
No,
Yeah.
because this was,
Oh,
I was factoring out. I had 1/3 here, and I subtracted 2/3, so 1/3 minus 2/3 is negative 3/3, which is negative 1.
It's like,
So now let's try to write this whole thing out. What is it?
I don't put your hair.
Okay, so the point is here we have 2/3. So can we combine that and say this is t squared minus 4 over 2t to the 2/3? Yeah?
So 1/3.
Wow.
Wait, yeah. Gotta times. Now what do they do with that?
It's like they got an 8 somehow.
Oh, because they distributed it.
But it's not 8t.
Oh my
Oh,
goodness.
yeah, it's 2t squared minus 8.
And the t squared minus,
Equal to negative. Oh, it's negative.
because this is t squared minus 4 minus I don't know. I think this is good enough. I think this is good enough, and I lost you guys. Hold on. Hold on. What are we doing next?
Back to code.
Yes.
Unit 3 is definitely a struggle.
I guess I should just wait. I was going to tell you guys the derivative of the trig functions, which is really fun, but I guess we can wait. Since we only have
Hold it.
8 minutes.